Machine learning has become kind of buzzwordy, but what is a machine learning model and how does it apply to what my day to day is? At its most simplest form, a machine learning algorithm is just something that maps historical patterns to outcomes. Once that mapping has been created, we can then take those mappings and put in new data as an input and predict outcomes that have not yet happened. Humans actually do this every day. People kind of forget that machine learning is based on the concept of human learning. So you can tell when a fruit is unripe, or it's ripe, or it's rotten. But how did you learn that? Well, in the past, you've tried various fruits, you've taken a look, someone has explained to you that this is a rotten fruit, maybe you've smelled it, maybe you've touched it. You can tell that an avocado that's a little bit darker and soft is ripe. And you can tell that one that's blackened is too ripe. You can see that bruised apples are bad and crispy apples are good. And all of these things are learned through past experience. And by collecting experiences with the fruits, we're actually now able to say what's a good fruit and what's maybe something that we would leave behind at the supermarket. Training the machine learning model is actually the same exact way, where we might take pictures of apples or pictures of avocados and have past examples that are labeled. This is a ripe avocado, this is an unripe avocado, and just give it hundreds of pictures of avocados. And over time, the algorithm actually learns how to map the different features, such as the color of the skin, towards an outcome like ripe or not. Practically, that means that anyone can use data science and everyone should be using data science to build machine learning models. There's always some outcome that we want to avoid or want to happen. Data science is constantly about good versus evil, and in almost every business unit, there's the outcome that we're chasing and all the other things we'd like to avoid. At the same time, there are the factors that cause these things to happen, and as long as we can describe a cause and effect and tie a data set to the cause and a data set to the effect, then machine learning is just a simple way to take what we were previously doing on intuition and put it into a computer as something to guide us in a more rigorous mathematical way. As an example, we say, oh man, like this customer, they definitely left us because they moved away from the branch and they're no longer close to one of our bank branches, and of course they're going to move to their local credit union and away from their old house's credit union. Well, that actually is describing something we can characterize in a machine learning model because we had an outcome, the customer left our bank, and a cause, the distance from the bank. In a different example, someone might be like, hey, like the semiconductor chips for this car are just not going to arrive on time. Everyone knows the supply chain is broken down. Well, that's another example of machine learning, but as long as we find the right data set. So the outcome there is the semiconductor doesn't make it into our factory in time, and the cause is the type of product it was or where it's getting shipped from. So don't get tripped up by the name. Even old school statistics like linear regression are part of the overall machine learning toolkit, which is saying there's some set of explanatory factors, an outcome that happens that we're trying to predict. And modern tools make it dead easy to actually combine these two sides of the data sets and produce a single mathematical model to predict the outcome. Let's just take a very simple example of what a machine learning model could look like. At this warehouse store, think about Costco. Our patrons have memberships. So we have true and false for whether some set of members cancel their members. We have true and false for some set of members who maybe kept or left our membership program. And we have some demographic attributes about this. At the most basic level, we could probably characterize this result just by coloring it in by one variable. Maybe we want to see how visit store relates to cancel membership. And so the most basic way we might do this is to visualize the results and see that those who cancel their memberships are much more frequently those who visited yearly. An obvious result, and obviously this is demo data. But from here, we might want to say, okay, so we know that some people cancel their membership at a higher rate when they only visit the store once a year. So now that we understand visits to store, we might also ask the question, hey, like, how does their gender relate to canceling membership? So then we can go ahead and plug this in and say, there's not a huge difference. Maybe guys cancel their membership at slightly higher rates, but there's not a meaningful difference. The question then becomes also, what about guys who visit the store once a year or more? Are guys typically in the lower visit category? Or are there overrepresentations, interaction effects? How do I put these two variables together? Am I confident that gender doesn't matter at all? Or does it just not matter in the first order, but after we consider gender and visit store, we get something out that's more interesting? That's when we can go to machine learning and say, just give me a model here where we target that cancel membership variable, plug in all the features that we have, all the things we could know about a customer. And now what this is going to do is it's going to search for a model that combines all these factors together and give me a quick explainer to say, what are the top variables to be explained? We see it has a store credit card, total years customer, staff satisfaction. All of these have a relationship. And we scroll down and we see that gender has a small, but not the smallest relationship with whether they cancel a membership. We can also use this machine learning model to examine individual. And we say this guy did not cancel their membership. So how do each of these variables contribute to their cancellation or not? And so maybe they had higher satisfaction, higher years of loyalty status, and all these variables combined together get plugged through the model and result in a single prediction. So in that sense, machine learning isn't necessarily something that is radically different. If I actually showed a long tenured store manager the profile of this person, they could probably intuit that they would cancel their membership or not based on some of these factors that we were talking about, such as whether or not they had a store credit card or the total years of being a customer. That being said, it's not a robust way to approach this problem to say, hey, store manager, look through 10,000, 100,000 members and warn me of which ones are about to leave. And so that's when we would come in with this machine learning model, plug in a new data set, and actually end up at a state where we can take our entire existing customer pool and make a prediction for every single person about whether they're going to leave.